Lise Meitner was born in Vienna, Austria, on November 7, 1878. She was the third of 8 children in a large Jewish family. However, Lise and all her siblings were baptized and raised as Protestant. Her mother was a Russian immigrant, and her father Philip was a lawyer from Vienna. Meitner always had an interest in physics from a very young age. Her parents supported their daughters with the exact same education as their sons, and Lise was given private tutoring sessions in mathematics. Girls were not allowed to attend the same high school as boys at this time, so Lise studied on her own for the entrance examination into the University of Vienna. At age 23, Lise was admitted into the University of Vienna. She was the first woman admitted into the physics lectures and laboratories at the university. Lise excelled in school, although she was the only woman there. She was treated as a parasite by her classmates, although her professors accepted her more graciously and helped her excel. Lise took many mathematics and physics courses in her first few years and later decided that she had a passion for physics. She eventually graduated with a PhD. Lise was invited by Max Planck to travel to Berlin and study with him in 1907. For years in Berlin, Meitner worked as an unpaid lab assistant and was not even permitted inside the labs. At this time, Einstein was also in Berlin, working with Planck and Ehrenfest. By 1912, Meitner began working in the laboratories with Otto Hahn, who became her research partner for the next 30 years. The two of them discovered new radioactive elements and learned about their physical properties. Hahn and Meitner were one of the first research groups comprising of both a chemist and a physicist. In 1915, Meitner worked as an X-ray technician on the front of World War I. When she returned after the war, she began teaching lectures at the University of Berlin. However, she was ridiculed by the press and by many students because she was one of the only female professors teaching such an advanced course. She continued teaching until 1938, when Hitler's new law came into action that prohibited famous scientists to travel abroad. Luckily, Meitner was able to escape to Sweden. However, Lise was not happy in Sweden and continued to write to Hahn about the physics properties being showed in his experiment. When Hahn first observed nuclear fission taking place, he wrote to Meitner, asking for help in describing what had just happened. Meitner realized that the nucleus was being split in two, which caused a tremendous amount of energy to be released. Meitner explained this all to Hahn, who published this new finding, not even mentioning Meitner's assistance. This new information led to the making of the atomic bomb. Meitner was awarded numerous honorary doctorates by universities in the USA as well in Europe. She was presented with the Enrico Fermi Prize and the Atomic Energy Commission. However, it was not included in the Nobel Prize that was awarded to Hahn for nuclear fission. Meitner died on October 27, 1968. Lise made many discoveries in her time researching. One of the early discoveries of Meitner was the Auger effect. This is a physics phenomenon where an empty space in an atom is filled by electrons from an outer shell and is accompanied by the emission of an electron. This electron leaving the atom carrying energy is called the Auger electron. It is named after the physicist Pierre Victor Auger, who discovered the Auger effect 2 years after Lise Meitner had already published a paper on this observation. I feel that the naming of the Auger effect is unfair and unjustified towards Lise Meitner. However, the other scientists did not know that she had already created it. I feel that her name should go into this effect as well. Lise's biggest contribution to the physics community, however, was explaining nuclear fission. While Lise was living in Stockholm, Sweden, her partner Otto Hahn came across a new discovery in the lab. He wrote to Lise, asking her about how the splitting of an atom took place. Lise wrote back to him, explaining the physics behind nuclear fission. So, I'm going to explain that now. A neutron is fired at an uneven and unstable radioactive element, such as, in this case, uranium-235. Atoms with an odd number of neutrons react best. An atom going through nuclear fission is similar to a drop of liquid. The neutron is absorbed The neutron is absorbed by the nucleus of the atom, giving the atom extra internal energy, similar to heating a drop of water. Before the splitting of the atom takes place, there is an intermediate stage of the atom when it becomes uranium-236. The extra energy in this excited state causes the nucleus to make an elongated shape, which decreases the strong nuclear force in the atom. The two new nuclei that are then created are called fission fragments. In the process of one atom splitting, there are usually a couple of neutrons given off. These neutrons go and fuel the fission of new atoms. Such a huge amount of energy is released in fission because the mass of uranium-235 is much greater than the mass of the fission fragments. This is because a large amount of energy is stored in the bonds of the atom. Because of the chain reaction created by the newly released neutrons, fission can create astronomical amounts of energy. The most acclaimed use of nuclear fission at the time was incorporating it into a bomb.
After the discovery of nuclear fission, the creation of an atomic bomb began taking place. The United States had a secret program called the Manhattan Project that had the top scientists in the world working on a way to create a bomb using fission. Meitner was invited to be a part in this initiative. However, she turned it down, saying that she didn't want to have any part in making a bomb. The first fission bomb was tested in a desert in New Mexico in 1945. The end of World War II came right after an atomic bomb was dropped on Hiroshima and then Nagasaki. Although the atomic bomb was instrumental in ending World War II, it killed millions of people and it had horrible effects on the environment. Immediately after a bomb is exploded, it causes fires and intense radiation. A bomb causes colossal effects of pollution in water and soil. It also releases plutonium, uranium, strontium, cesium, benzene, PCBs, mercury, and cyanide into the world, which these hazardous substances can last for thousands of years. The Meitner family contributed to a large part of Lise's success. Both of her parents believed in educating their daughters just as well as their sons. So even though girls stopped attending school at the age of 14, Lise and her 5 sisters all had private tutors come to their home. Lise's parents encouraged her to go to university and encouraged her to follow the passion that she had in physics. Their guidance and encouragement acted as an inspiration for Lise. Otto Hahn was Lise's partner for over 30 years. However, even though they acknowledged each other as equals, Hahn did not even mention Meitner in his publication about fission. Hahn went on to win the Nobel Prize, and Meitner was left out. This exclusion was largely due to sexism. Meitner was not seen by many on the Nobel Prize panel, a true equal to Hahn. Another major contributor to Meitner being left out was the fact that she was from a Jewish family in a time when Jewish people were being oppressed. Now, if you look up nuclear fission in any country, it will say that the chemist Otto Hahn, pictured here, discovered fission, while the truth about his partnership with Lise Meitner remains a mystery to many. Otto Hahn is known as a German chemist and a researcher who is considered to be one of the most influential nuclear chemists in history. He accordingly pioneered the fields of radiochemistry and radioactivity, and is known to some as the father of nuclear chemistry. I hope you learned a lot from this presentation, and I hope that you learned about how fission happens, as well as atomic bombs. I hope that you learned a lot about Lise Meitner's life, as well as the ethical issues concerning the involvement of sexism and racism in science. On the next slide is my references from this project, and I hope you enjoy your day.